this episode, we're going to look at a toolchain called DragonRuby, which allows developers the ability to build apps and games using Ruby. And it's not the full-blown Ruby version, and it's more comparable to something like mRuby. And for full disclosure, they did give me a license of DragonRuby to play around with. It is a $40 license. And they also gave me 5 licenses to give away to the community. And I'll create a tweet on how you can enter to win one of the licenses, but it's going to run in July 2019. But once you purchase DragonRuby, you're going to be able to download it from itch.io. And when you go to download it, you'll see that it supports several different platforms. You can use it on Mac OS or Linux, even the Raspberry Pi, or you can use it on Windows. And the nice thing about when you create a game or application with DragonRuby is that it's going to be cross-platform on all of these different operating systems automatically. And once you download and extract the zip file, you'll see that there's a lot of different files within here, and there's a few different executables. And so you'll just want to put this folder somewhere, and from within there you can start creating your projects. So in this episode, we're going to look at creating a game called Squares. And so to run our game Squares, we're going to just run DragonRuby, and then we're going to pass in our Squares directory. And this is a pretty simple game. You basically just have to keep away from the squares, and if you accidentally run into a square, then the game will reset. But we have this little heads up display, which shows us how far we've gone and what our high score is. So it's just a really simple game and keep away, and as time progresses, the squares start adding in more and more and more, and they also start getting faster and faster. And in the samples directory, they have a lot of different demos that you're able to go in and run these to see the different kind of interactions that you can do. For example, if you want to learn how to save and load a game, then they have an example for that. Or if you want to do some interactions with the mouse click or the mouse move events, then you're able to see some examples of how they do that. And so to get started, I'm going to create a new directory, and I'm just going to call it Drifting Squares. And when we go into that directory, I'm going to create another directory called App, and then I'm going to just simply touch a file in the app folder called the main.rb. And then I can go ahead and launch my editor. And so basically within the application, we're going to have a method called tick. And this method tick is going to get called 60 times a second. So that's really the life cycle of a DragonRuby application, is that it just keeps calling this tick method over and over and over. So for example, if we have something like the arguments.state, so the arguments is going to be a global kind of a state store that we're able to use. And if we create a variable time, if we do something like equals 0, and somewhere later in the application, we have an increment of our time, the main problem is going to be is that 60 times a second, this time variable is going to get set back to 0. So instead, we can do something like a double pipe equals 0, so that when the game is first ran, it's going to set the time to 0, and then each subsequent tick, it's not going to execute that line again, or rather, it's not going to set it to 0 because it already has a value. And so within our game, we're also going to need something to track our high score. So we can set our high score, and we're going to set that to 0 as well. And then we're also going to need to keep track of the cubes on our screen. So we can set a state for our cubes. And for right now, I'm just going to leave this as an empty array. And then finally, we need to know when the last split was, or when the last generated square was, because we're not going to want to flood the screen 60 times a second with a new cube. And again, we'll set this equal to 0. And so I don't want to keep all these initializers within our main loop. So I'm going to just create an initialize game method, and then we can define that, and then we can just paste those in there. And so once a game is initialized, let's go ahead and display our heads up display. So I'm going to create a method called display HUD, and within this method, we can take our state time, and we can do a plus equals 1 out of 60 because we're refreshing the screen 60 times a second. And with the args, there's also another method called the outputs. And with the outputs, we can generate a label, and the label is an array, so we will need to pass in a few different options into this array. And so the array that we're going to pass into the labels, we're going to need our x coordinates, our y coordinates. And basically where I got that number from is that on the screen, the very bottom left corner is 0.00. And if we move up 720 pixels, then we're on the very left hand side. And so we're at 720. And the top right screen, it's going to be 1280 by 720. And these are just fixed numbers for our screen size within DragonRuby. So essentially we're saying that over 10 pixels and up 700, we want to put this string. And so we're going to just display the time, and then we can get our args, the state, time, and let's just make this an integer, so it's going to trim off any decimals. We can create another label, and this time, let's move it down 20 pixels. And we'll just write the number of cubes. And to get the number of cubes that we have on the screen, we're going to be injecting the cubes into this state. So we can simply just get our cubes.size. And for the high score, we have a variable for that as well. And again, let's move this down 20 pixels. So we'll move it down to 660. And then we can simply just display out our high score. Oh, and one mistake here is that we do need to make these labels labels. And so if we were to run the game, you can see that now we have the time incrementing, but we don't have any cubes. So next, let's go ahead and get a cube to display, and then we'll just have it start moving across the screen, bouncing off each one of the edges. And so for our cubes, I'm going to create a method for our cube, and this is simply just going to be a hash. So we're going to first generate the x and y coordinates for the cube. And so for the x screen size, we know that this is 1280 pixels, but we want to randomly generate it on the screen, so we can multiply this by rand. For the y, we're going to do something very similar, except this is going to be 720 pixels times the random number. And then we need to keep track of the direction for the cube. So I'm going to have an x direction, and we'll start it off going forward. So we could really just use a symbol or anything here really. We're just going to need to know what the x direction value is so we can modify it as needed. And then we're going to also have a y direction. And since y can go up and down, I'm going to have this one called climb. We're also going to need to set the width and also the height of our cube, and then also the speed in which the cube can go. So one thing that I like to do up at the top here is I'm going to create a mode. And this mode is simply just going to be a hash, and let's just say our size is 35, our speed, let's make this 0.05, so it's going to go kind of slow. And then eventually, when we go to set this, we're going to need to know how often we want to generate our cubes. So I'm going to have a generate, and let's just say that a generation value is going to be 1 cube per whatever this value is. So we're going to create 1 cube per second in this example. So now that we have some default values that we're able to use, so anyone coming into this game, you can just document what these 3 different values are so that they can modify it to increase the difficulty or make the game a bit more simple. So because we are working with cubes, we can get our mode and then the size. And I had memoized this just so we're not recreating this hash every time. Instead, now the next time we called mode, it's just going to read from the hash that it was already assigned to. And then for the speed, we can get our mode and then the speed. And so now that we have a cube defined, we can take this method and then we're just going to insert it into the array. So basically when the game starts, we're going to start with 1 cube on the screen. And so once we initialize the game, once we display our heads up display, we're going to say move cubes. And so as I'm building this, I kind of like putting these in order of importance. So the move cubes is going to go after the display HUD, and the display HUD goes after the initialized game. So down at the bottom, I'll create our method, move cubes, and then we can get our arguments, outputs. So if you haven't realized yet, the outputs is where we are displaying stuff onto our screen. And we're able to create a solid. And a solid is just going to be a simple square or whatever shape that we determine that's going to get displayed on the screen. And so we're going to inject into here our arguments.state.cubes. So our cubes is an array, and right now we're going to just loop through each one of them. And if you remember, our cubes is just simply a hash. So 60 times a second, we're going to inject into our solids, which is going to display an object on our screen, and we're injecting in these lists of cubes. And this is going to expect an array back, and then we need to give it our x, y values, and then also the width and height. So we can pass in our hash and x, and I'm going to just copy this out here to keep it simple. And so for our x position, the second value is going to be our y position. We then have our width and then also the height. And if you remember, we are getting these values from our cube that we are passing in. And this cube is getting passed in at the initializer. So when we go to initialize the game for the first time, we're setting it equal to an array, and then we have just one cube in there. If we wanted to start out the game with 2 cubes, then we could do something like cube, cube, and then it would insert in 2 cubes into the game. And in the move cubes, we're just simply looping through those cubes that we set up in our initializer. Oh, and we had to put our do in here for our block. And so if we come back to the game, you'll see that there's no cubes on the screen even though we are injecting one. And that's because this game is still running. As we are making changes to the application code, the game is going to automatically refresh, but we've already initialized our cubes variable, and so we need to reset the game. So if we hit the back tick, we then get our console, and from within here, we can call the $dragon.reset. And once we do that, you can see that it reset the game. Now we have 1 cube, and our timer is now starting over from 0. And on the screen, we have our 1 cube. So let's go ahead and start moving this cube around the screen. And so this is where things get a little bit more difficult. So I don't want to put all the logic in here. Instead, I'm just going to say calculate the cube movement. And then we need to pass in our particular cube. And in this case, we're just going to pass in that hash. And so in our method below, we need to first work with the Xdirection. So if you remember, at the top, we have our position, and it's getting randomly generated on the screen in the X direction, then also the Y direction. And if you also remember, our X direction is forward, so that means that we're going to move it to the right of the screen, and the Y direction is climb, and that's going to be up. So we can take our hash, and then the X direction, and we want to set this equal to forward if the hash X position is less than 0. And if you remember, 0 is going to be the very left side of the screen, and then 1280 is going to be the very right side of the screen. So I'm just going to copy this out, and we're going to set the direction to backwards if the X direction is greater than, and then we're going to set this to 1280. But the problem here is that, as you imagine, everything is getting referenced on the bottom left. And so we have an initial width of our cube is 35 pixels because we set the cube width down here to our mode size. So actually, when we say that it is more than 1280, that's going to be in the reference of the left side of the square. And instead of the left side of the square, we want to reverse the direction if the right side of the square touches the right side of the screen. So we need to subtract the hash and then the width of our cube. And we can do something very similar here. So I'm going to just copy these out, and instead of the X direction, we now want to deal with the Y direction. And so we're going to set the Y direction to climb if the hash Y, so the position of the cube, is less than 0. And you can see my little linter is saying that we could change this to .negative instead if we wanted to. But because we are dealing with math here, I think it might be more simple if we keep these values, but you can be the judge of that. And so the Y direction, instead of climbing, we're going to say that we want it to move downwards if its value is greater than 720. And instead of the width, we want to check the height. It's a square, so the width and height are the same values, but if you were to modify the game to be rectangles or something like that, you can make it a little more difficult. And so now that we have the directions in place, we can change the position of the cube. So for the X direction, we're going to increment this by our hash speed. So 60 times a second, we're going to be moving it at our speed, and our speed we had set to 0.05. So that's not a very fast moving cube. But right now, this is always moving it in a single direction, and that's going to be going right because we're incrementing it. And we can multiply this by our direction. And so we can check this direction. If it is equal to forward, If it is equal to forward, then we're going to multiply it by 1. Otherwise, we're going to multiply it by -1. And so that's going to take care of, once it hits the right side of the wall, it's then going to be set to backwards, and so it's going to start subtracting from our x value. We can copy this out and do the same thing for the y value. And so the y value is going to keep increasing, but once it hits the top of the screen, it's then going to start subtracting the y value. And so now you can see that once we run this, the cube is now hitting over to the right hand side, and then it's now reversing the direction. And if we come up here, and if we change the speed, I'm going to just change it to 1. We can then come up and then run the DragonRuby reset. And I do have a mistake here. I forgot to change this from forward to climb on our y values. And so now we can see that the cube is moving around the screen. And if we wanted to make it even faster, then we can set the speed to 5 or something like that, and then it's going to be quicker. But for now, I'm going to change it back to 0.05. So now that we have the cube bouncing around the screen, let's make a collision with the mouse. So if it collides with the mouse, then we're going to reset our game. Otherwise, if it does not, then we're going to speed up the game. And so I'm going to create a reset game method that we're going to be able to use. And to reset the game, we're going to set our cubes equal to just a simple cube. And so that's going to remove all the cubes from the screen, and then in our outputs, we're just going to be injecting in the one solid. We can set our time equal to 0, and then we also want to reset the last split. We're going to see why this one is important, because when we go to create an additional cube, so meaning that we're going to inject in a new cube into this array, remember that this game is happening 60 times a second. And so that 60 times a second, we may only want to generate a cube once every 1 second or 10 seconds or something like that. But because we are dealing with integers, and even with our time, we're incrementing that by 1/60th of a second, there's a chance where it could glitch and then we get 2 cubes generated instead of 1. So in our main loop, I'm going to create another method, and this is going to be the check collision with mouse. And I'll come down to the bottom of the screen and I'll create that method. And so if we only had 1 cube in the game, then this wouldn't be too difficult, but we actually have several cubes that could potentially be in the game. So we need to actually loop through each one of the cubes. So we can do our cubes and loop through each one of them. And so we're going to have basically a if collision, then we're going to reset the game. Otherwise, if there was not a collision, then let's say we're going to take our hash speed and we're going to set this equal to the hash speed, and we're going to increment this by 0.05, and then we're going to pass in something like 10. So we're setting the hash speed equal to this array, but we actually want the minimum value. And that's basically going to create an upper level of how fast a cube can move, because we don't want a cube to move too fast on the screen, because then you're not even going to be able to see it to interact with it. So on an array with multiple values, we can call .min to get the least value of the two, so the fastest that this game will ever move is at a speed of 10. So for this collision, we can get our arguments, .inputs, and then mouse. So we have access to our mouse, and then on this mouse object, we can get the X position. And we want to check to see if this position is greater than the hash, the X position of the particular cube that we're looping through. And we also want to check if the args, inputs, mouse, Y position is greater than the hash of the Y position. So far, we're checking if the mouse is to the right of the cube and if the mouse is above the cube. So if we do this again, so I'm going to just simply copy this down. And so now if we check if the mouse is to the left of the cube, but we want to make it to the left of the right side of the cube, so we need to add in the hash width of the cube. And so far for this particular cube, we're saying that is the mouse to the right of the cube. And we're also checking if the mouse is above that cube. And then we're checking if the mouse is to the left of the cube, but to the left of the right side of it. And for the Y value, we can then check if the mouse is below the cube, but then we want to add in the hash H. And so this is going to check the top side of the cube. And so now when we run the game, we can try to collide with it. And as we collide with it, you can see that it resets the game. And if we leave it alone, you can see that the cube starts speeding up more and more, but it's going to max out at a speed of 10. So no matter which direction we approach it from, it's still resetting appropriately. And so now, let's also increase the number of cubes that we have on our screen. And so we can do something like a split underscore cube, and this is just going to be a method that we create, and we want to only do this if there was no collision. So if there was a collision, then we're resetting the game. Otherwise, we are speeding up the cube. And then also, we're going to split the cube if our state time, and let's make this an integer so we're not dealing with fractions. And we're going to get the modulus and then our mode generate. And if this is equal to 0, then we'll split our cube. And so here, I'm going to create a guard clause. And this guard clause is going to state that if the args of the state time minus the args of our state last split, and if you remember, our last split was set to 1, if this is less than our mode generate, and let's just add a little buffer in there, plus 1, so we're basically adding 1 second to this, then this means that we're hitting a situation where we shouldn't be splitting, but just based on the times, it's actually coming out to where it wants to split it. And to create a new cube, all we have to do is take our args.state.cubes, and we just need to inject into this another cube. So if you remember, this cubes is something that we set at the beginning of the game with just one cube. And then in the moveCubes method, what we're actually putting out onto the screen 60 times a second is our array of cubes. So if we want to put an additional cube on the screen, all we have to do is then inject into our solids an additional cube, and we're able to do that because this cubes variable is persistent. And finally, we can take our args.state.lastSplit, and we can set this equal to the current time. So that's going to be our args state time. And so now, if we let the game go, we now start seeing some additional cubes forming on the screen, and as long as we avoid them, then the game won't reset. But the next problem that we have is that our high score isn't updating, and we want the high score to be the total number of cubes that are appearing on the screen once the game has reset, as long as it was higher than the previous number. And so, to do that, underneath the HUD, we can just set a set score. I'll then come down under the HUD method, and I'll create a method, the set score, and within here, we just want to set the args of the state high underscore score, and we want to equal this to itself, or we can set it to the time or the number of cubes. I think the time is actually going to be a better indicator of our high score. And we want to get the maximum value. And again, with the time, let's just go ahead and make sure that this is an integer. So now we can see that our high score is incrementing, and it starts over once we have a collision, and the game will just keep going from there. And so back at our main folder, you can see that there is a DragonRuby publish. So if we run this on our drifting squares, you can see that it failed to load the game metadata. And so if we create a new folder, if we call this the metadata, we can create a new file, and we're just going to call this the game underscore metadata.txt. And then I'll just paste in the values. But basically, you need to have your dev ID, a dev title, a unique game ID, the title of your game, the version number, and then an icon. And so I'm going to just drag in the DragonRuby icon, and we'll see if this works. So we can run this again, and you can see now it is compiling the game, and it's actually going to publish it. So we can give it permissions to publish our game. And if we go back to the console, when we try to publish it, you see that we get an invalid game. And once you do that, if you go into your cd.dragonruby, so it's a hidden folder, if we list out, you can see that there's a few different things. The builds is where it's actually going to build out your application, and then the itch.io butler, that's going to be the application that's used to publish your game up to itch.io. If we go into the builds, you can see that we have a compiled version for Windows, Mac OS, Raspberry Pi, Linux, and then also an HTML game. So your game will be able to be played directly within the browser. And the reason why the game wouldn't upload before is because we have to come over to itch.io, game, new. You can also access that once you log in to upload new project. And you'll need to fill out some information with the title and the project URL, and you just want to make sure that you copy this information directly as you have it in your game metadata. And if you were to scroll down, you can set some pricing for your game. And instead of uploading files for our game like we saw in the builds directory, we're going to just skip that, and instead we're just going to continue down and create our game. And so now when we go to publish our game, it's going to build everything, and then it's going to start pushing it up to itch.io. And once it's been published, we should be able to come to our game space, and then we should be able to download and distribute our game. Well, that's all for this episode. Thanks for watching. For more videos, check out DragonRuby.com.